In this round of grandiose billiards later, Uranus will plunge past Neptune, leaving the planetary group and turning into an interstellar space apparatus in the gigantic spread of the universe. Mankind has consistently looked to push the limits of investigation to reveal the secrets concealed inside the profundities of the universe. For over 4 decades, one shuttle has exemplified the hungry curiosity and persevering pursuit of knowledge, Explorer 2. Yet, as of late, Explorer 2 has made a discovery so serious that it is now turned around, constrained by a power beyond our awareness. What might this discovery be, and what does it reveal about the secrets of the universe? Join us on this journey beyond the edge of the universe as we unwind the mysteries of Explorer 2's new unnerving revelation. In a critical moment of human effort, in the midst of the background of 1965, the universe saw the introduction of an unusual chapter in space exploration. Leading the charge was Gary Flandreau, an illuminating presence among NASA's Center of Brilliant Minds, positioned at the Jet Propulsion Laboratory. Flandreau's task was, however dangerous as it might have been, new, to arrange the trajectory of a shuttle foreordained for the far-off reaches of our solar system, where the gas giants Jupiter, Saturn, Uranus, and Neptune remained as enticing secrets waiting to be unveiled. Furnished with little more than a handy pencil, an image of precision engineering during a time before digital dominance, Flandreau set out on his mission. His careful calculations and keen observations soon bore fruit in the form of a discovery that would redefine the boundaries of space exploration. Delving into the archives of celestial mechanics, Flandreau identified a cosmic dance set to unfold in the late 1970s and early 1980s. It was an intriguing arrangement of the gas giants, a grand celestial movement unnoticed for centuries. This arrangement promised a cosmic spectacle, with the planets forming a magnificent necklace with Earth at its center. However, the significance of this arrangement extended far beyond its visual wonder. It presented an extraordinary opportunity for spacecraft traversing the inner solar system. As each giant orbited in concert, they created gravitational highways, a celestial slingshot effect that could propel a spacecraft from planet to planet, saving travel time and conserving valuable fuel. Flandreau's calculations not only revealed the potential to shorten the journey to Neptune but also uncovered a phenomenon known as gravity assist. This method involves using the gravitational pull of planets to slingshot a rocket, increasing its speed and conserving fuel. The alignment of Jupiter, Saturn, Uranus, and Neptune allows for such efficient travel, creating a kind of celestial freeway. This dramatically reduces travel time between Earth and Neptune. NASA's decision to seize this opportunity was evidence of its agility and determination, despite vast challenges. The launch of Explorer 1 and Explorer 2 marked not only a milestone in space exploration but also a triumph of human creativity and resilience. What's truly remarkable is the longevity of the Explorer spacecraft. Designed with durability in mind, they were equipped with instruments capable of enduring the harsh conditions of space for decades. Despite being launched in the late 1970s, their technology continues to function, albeit with certain limitations due to aging equipment. As Explorer 1 and Explorer 2 continue their journey through the universe, they become ambassadors of mankind, sending messages from Earth in the form of golden records containing sounds and images representing the diversity of life on our planet. These records act as a time capsule, a portrayal of humanity's network, ready to be discovered by any intelligent beings they may encounter in the vastness of space. Their mission has far exceeded expectations, providing significant insights into the outer reaches of our solar system and beyond. Daily, they send back data that expands our understanding of the universe, reaffirming the importance of space exploration and unraveling the mysteries of existence. Initially planned for only 4 years, the interstellar explorers embarked on a remarkable journey that extended far beyond their intended duration. Launched in 1977, the Explorer spacecraft proved to be adaptable travelers, surpassing expectations and rewriting the textbooks of planetary science as they ventured through the depths of space. Explorer 1 and Explorer 2 provided mankind with incredible insights into the outer reaches of our solar system. These brave probes captured stunning close-up images of Jupiter's swirling storms, Saturn's glorious rings, and the intricate landscapes of their diverse moons, from the icy waters of Enceladus to the volcanic eruptions on Io. Each discovery revealed a dynamic and complex universe that challenged our understanding of planetary cycles. Explorer 2, in particular, etched its name in the annals of space exploration by becoming the first spacecraft to pass near Uranus in 1986. Its flyby unveiled a mysterious ice giant surrounded by an atmosphere of hydrogen, helium, and methane. Just 3 years later, Explorer 2 again made history as it flew by Neptune, providing humanity with its very first close-up look at the distant blue planet and its enigmatic moon, Triton. However, perhaps the most astonishing aspect of Explorer's journey lies in its perseverance. Despite traveling over 14 billion miles from Earth, the spacecraft continues to communicate with researchers, sending back valuable data about the interstellar medium it now traverses. These remarkable probes, reminiscent in size of a unique Volkswagen Beetle, have exceeded all expectations and continue to push the boundaries of human understanding of the universe. The extraordinary journey of the Explorer probes began with a challenging gravitational assist, a maneuver never before attempted by any spacecraft. This decision showcased the innovative spirit of the mission, setting the explorers apart as true pioneers in the realm of space exploration. Navigating through the vastness of space was no easy feat. The margin for error was incredibly thin, with deviations measured in mere minutes, highlighting the precision required for such interstellar travel. Numerous meticulous efforts were made to ensure every aspect of the journey was carefully planned and executed. As the probes embarked on their voyage toward Jupiter, they ventured 10 times farther from Earth than the closest planet, Mercury. Their trajectory led them through the perilous asteroid belt, a region of space fraught with countless celestial bodies, each representing a potential threat to the mission's success. This journey through the asteroid belt sparked intense discussion and speculation among scientists and engineers during the 1970s, as the precise density and configuration of the belt were not fully understood at the time. Despite these uncertainties, the earlier Pioneer 10 and 11 missions had paved the way through the seemingly dense asteroid belt unscathed, demonstrating that such an excursion was indeed possible. This accomplishment not only showcased the resilience of the spacecraft but also set the stage for the groundbreaking Explorer missions. However, the challenges for the Explorer probes were far from over as they ventured further into the universe, encountering various obstacles and secrets, each introducing new amazing open doors for disclosure and development. With a simple 69 KB of memory, scarcely enough to store a little picture record by the present norms, the Explorer space apparatus faced an immense challenge as they embarked on their excursion. Their memory limit was equivalent to just a fraction of what the regular cell phone can hold. Featuring the extraordinary imagination of the specialists who designed them, these brave pilgrims depended entirely on their onboard knowledge to navigate the enormous expanse of space. To put it into perspective, imagine graphing a course through an interminable ocean with just a compass and the brains to guide you. That was the level of illumination the space apparatus operated at before the era of distributed computing and fast internet. The data gathered by the instruments on board was stored on old track tape recorders, the same kind of tapes grandparents might have used to listen to music in their cars. It's astonishing to think that such obsolete technology was responsible for preserving the important scientific revelations made by the Explorer missions. Despite their limited resources, the Explorer spacecraft communicated with Earth using a transmitter that was about as powerful as a refrigerator bulb. However, with the help of giant 12-meter-wide radio antennas, they managed to send and receive signals across the vastness of space. Imagine being so far from home that it takes over 18 hours for a message to reach its destination. That is the reality of the signals sent by Explorer 2 as it ventured deeper into the universe. Each piece of data, each image, each whisper from these distant Voyagers had to cross unimaginable distances before reaching the eager ears of scientists back on Earth. As the explorers traveled further from Earth, they had to contend with interference from every conceivable kind of human-made device, radios blasting music, TV broadcasts, and the constant chatter of cell phones. Nevertheless, the explorers have defied the odds and continue to astonish space experts with remarkable discoveries. Their journey through the interstellar void has not only changed our astronomical playbook but has also transformed our understanding of the mysterious realms of space that extend far beyond our solar system. One such enigmatic event is the complex cloud, a heavenly congregation of comet-like elements held together by the gravitational pull of the Sun, extending most of the way towards the nearest star. It remains a distant and captivating domain. The explorers are slowly yet steadily advancing toward this intriguing objective, hoping to unveil its mysteries and comprehend its role in shaping the structure of our solar system. However, the journey through interstellar space, where the solar wind phenomena give way, offers a more accessible front for exploration. Here, the heliopause marks the line between our local planetary group and the immense region of interstellar space, signaling the start of strange territory. It's a region where the influence of our Sun fades, and the immense power of the interstellar medium begins to assert itself. Estimates of the heliopause distance were conflicting, with some suggesting it to be around 50 astronomical units. This uncertainty prompted a surge in funding for the Explorer mission as researchers sought to shed light on this pivotal boundary. Yet, as the spacecraft withdrew from this milestone, scientists were astonished to find no typical indications of interstellar travel. This surprising revelation has sparked great debate and led scientists to reconsider existing models of interstellar space travel and the dynamics of the heliosphere. Moreover, the explorers have provided invaluable data on the composition of the interstellar medium, contributing insights into the cosmic climate beyond our solar system. This information has transformed our understanding of the universe and opened new avenues for exploration and discovery. As the explorers continue their journey into the unknown depths of space, they embody humanity's unquenchable curiosity and relentless quest for knowledge, pushing the limits of what we think is possible and unveiling the secrets of the universe, each revelation, one step at a time. One of the highly anticipated scientific milestones that researchers were eagerly awaiting was the sudden surge in high-energy particles known as cosmic rays. These particles often originate from supernova explosions and other cataclysmic cosmic events, traveling at speeds approaching the speed of light. While these cosmic rays pose a significant threat to spacecraft and even human astronauts, most lower-energy particles are effectively blocked by the vast magnetic shield created by our Sun's heliosphere. This shield serves as a protective barrier, safeguarding our inner solar system from most external cosmic threats. As the Explorer spacecraft continued its extraordinary journey into the interstellar medium, researchers were not only observing the increase in cosmic rays but also studying any changes in the prevailing magnetic field. This magnetic field is influenced by the ionized gases permeating interstellar space and nearby stars. The assumption was that this magnetic field direction would vary from the magnetic field within our heliosphere. However, when Explorer 1 achieved a significant milestone by breaking through the heliopause, the outer boundary of the heliosphere, on August 25, 2012, scientists were baffled by the absence of any significant shift toward the surrounding magnetic environment. Fast forward to November 2018. Explorer 2, the twin shuttle to Explorer 1, set out on its journey to the heliopause, much like its ancestor, Explorer 1. It navigated huge distances and sent priceless information back to Earth, enhancing our understanding of the external limits of the nearby planetary group. Notwithstanding the expectation and energy surrounding Explorer 2's landing in the heliopause, researchers were indeed bewildered by the information it communicated. Like Explorer 1, Explorer 2 identified no massive changes in the situation of the magnetic fields, testing existing hypotheses and leaving specialists wrestling with new inquiries regarding the elements of interstellar space. These pivotal missions by the Explorer space apparatus not only expanded our insight into the universe but also highlighted the unlimited potential outcomes of human exploration beyond the bounds of our home planet. As these valiant probes continue their journey into the vastness of interstellar space, they serve as signals of human curiosity and perseverance, inspiring generations to come to explore the unknown domains of the universe. However, none of the current models could make sense of this intriguing inconsistency. When Explorer 2 finally arrived at its objective, the solar wind, a consistent stream of charged particles radiated by the sun, was viewed as at its strongest. This startling observation indicated that the boundary of the heliosphere, known as the heliopause, may extend much farther than previously assessed, potentially beyond the 120 astronomical units initially assumed. As the Explorer probes wandered further into the unknown region, where the solar wind meets the interstellar medium, they uncovered an abundance of intriguing data. Among the revelations were subtle yet critical small-scale changes happening close to the heliopause. These variations appear to be affected by the complex interaction between the heliosphere and the surrounding interstellar environment, revealing insight into the unique nature of this boundary region. Despite the complex changes observed on a smaller scale, the Explorer probes detected surprisingly little variation in the magnetic field at great distances. This revelation baffled researchers, raising questions about the probe's possible departure from the heliosphere's fierce boundary. Would they ultimately break free from the heliosphere's grasp and experience the true magnetic field of interstellar space? Debate among specialists heightened, with some speculating that the Explorer probes could still be within the heliosphere, while others pointed to compelling evidence suggesting their venture into interstellar space. This evidence included a remarkable increase in the detection of cosmic rays and plasma density, indicating a transition into a new vast domain beyond the Sun's influence. Tackling this mysterious puzzle is akin to interpreting the complex dynamics of a goldfish bowl from the perspective of the fish inside. To gain a comprehensive understanding, researchers recognized the need to send an interstellar probe capable of providing a significant outside perspective on this intriguing boundary region. Amid the rapid advancement of technology, the Explorers stand as remarkable relics of space exploration history, created with creativity and foresight. These interstellar trailblazers are powered by a unique combination of rare engineering and timeless innovation, venturing into the universe with hardware tracing back to the 1970s. The Explorers possess a certain charm that captivates the imagination, their rugged frames house instruments designed with precision, each part meticulously crafted to endure the rigors of space travel for decades. Despite the passage of time, these instruments continue to operate with remarkable efficiency. The power source for the journeys is equally intriguing, utilizing the heat generated from the radioactive decay of plutonium. The spacecraft convert thermal energy into electrical power, an engineering feat that has sustained their missions for over 50 years. This unconventional power supply has enabled the Explorers to travel far beyond the bounds of our solar system, sending vital data back to Earth with unwavering confidence. NASA's meticulous approach to managing the Explorer's dwindling power supply highlights the agency's commitment to maximizing the scientific potential of these aging spacecraft. Every decision made by mission engineers is a delicate balance between preserving essential instruments and extending the Explorer's operational lifespan. Despite facing challenges such as decreasing power output and extreme temperatures, the Explorers continue to astound. The magnetometer and plasma science instrument are expected to be the last devices to cease functioning, as they are housed within the spacecraft's main body, kept warm by the computer's heat. Other instruments are connected to a 13-foot-long fiberglass arm. If all goes well, researchers could extend the missions of the Explorers until 2030. However, the true game-changer is power. Despite challenges, the Explorers will continue to push ahead. It's an incredibly long journey, spanning 16,700 years. Explorer 1 will swing past Proxima Centauri, our nearest stellar neighbor, while Explorer 2 will do the same 3,600 years later. They will continue orbiting the Milky Way for millions of years, long after our Sun disappears and its protective bubble, the heliosphere, vanishes. These resilient spacecraft will still be there, largely intact, unlike our little blue planet. Perhaps they may even convey a final message during their endless journey. But if they do, it will not be via radio, and there will be no humans to receive it. The Explorer adventure is a tribute to human exploration and scientific curiosity, pushing the boundaries of reality.